Yes, on Friday, we're actually going to hit geometry proofs, okay? But today should be easier because it's all based on algebra. So before we get started, I want to preface the whole lesson with this. I am going to require you to set up your problems different than the book. So if you look at the book or look at the book examples or check your answers in the back, they will not be in the format that I am requiring you to do. So make sure that you're checking the video, you're checking your notes, you're basing it off of what I'm telling you right now, not what you see in the book. Okay? And the reason I'm going to have you do it in a different format is so that when we get to Friday's lesson, it's easier because we practiced the format today when we were doing our algebra proofs. It'll make it so much easier on Friday, okay? So just keep that in mind. A proof, what is a proof? A proof is basically an argument that uses logic, definitions, properties, previously proven statements like theorems, postulates, to show that a conclusion is true. So basically what's going to happen is they're going to give us some given information and they're going to ask us to prove something. And we're going to have to give a step-by-step logical process and back up every step we're doing with some sort of definition, theorem, postulate, property, every step. Proofs are harder for my pre-AP students than they are for my regular students. And that may seem weird, right? The reason they're harder is because you guys are so smart that you want to skip steps in your mind. You think, oh, well, we already know that. A proof is a step-by-step process, so you can't skip steps. You have to give every single detail. And so sometimes that makes it harder because you're already 2 steps ahead in your mind figuring out what's going on. So you're going to have to slow down and you're going to have to make sure you're giving every single step, okay? When we write our proofs in this class, we are going to focus on getting amazing at one kind of proof. So every proof that we're going to do will be 2-column. There are other kinds of proofs, and we're going to talk about them next week, but we will not practice writing them in that format. We will do 2-column proofs. And what I mean by 2-column is we are going to set up what looks like a T-chart where there are 2 columns. So you're going to create every single time a 2-column chart. You're going to label the left side statements every time. And then you're going to label the right side reasons. And this is what the book is not going to do on the algebra proofs today, but you're going to set up every algebra proof this way today, okay? When you write a proof, you will always number the statements and you will number the reasons. And those are very simple little details that I will give you points for or take away points for if you don't do them. So make sure that you are setting it up 2-column statements, reasons, and numbering. You're going to write down your statements on the left and the reason you know it on the right. So the reasons are going to be definitions, theorems, postulates, properties, things that we have learned, okay? Today it's going to be easier because our statements are going to start with an algebraic equation. And you're just going to be solving that algebraic equation on the left side. And on the right side, you're going to be telling me why you can do every step you do, which is basically going to be just properties today. Okay? So if it says write a justification for each step, you're writing a proof. Okay, so some properties you're going to use for that right column reasons. The first 4 are things that you learned back in Algebra 1 or maybe even middle school before then when you first started solving equations. I am going to be picky. You cannot abbreviate. No abbreviations. No abbreviations. And or with that, though, I will let you use symbols. So on all of these, notice they end with of equality. If you would like, you can cross that out and just use an equal sign. So of equals, of equals. And that'll make it a little shorter since I'm not letting you abbreviate anything else. Okay? But you will write addition property of equality, subtraction property of equality, multiplication property of equality, division property of equality. The other thing I will point out here is these properties are what we're using to solve our equation. But in order to use them, you have to do it to both sides of the equation. Both sides of the equation. Most common mistake are students trying to use addition property when they didn't really use addition property. And I'll show you an example in just a second. The addition property, though, says you can add something to both sides of the equation. Or subtraction is from both sides of the equation. Multiplication, you're doing it to both sides of the equation. Division, you're dividing on both sides of the equation. Okay? So here's an example of where students are incorrectly using addition property. If I wanted to solve for x, what would be my next step? Okay, you would add 2x and 3x and you would get 5x. And students will often put addition property of equality. That was not addition property. You did not add something to both sides of the equation. I heard somebody say it, what did you really do? Combine like terms. So you're going to add in your notes down here another option for a property, combine like terms. Or, if you would prefer to not write 3 words and prefer to write only 1 word, you could also just put simplify. And I'll accept either one. So what we did to get from step 1 to step 2 was simplify or combine like terms. We did not use the addition property. So that's why I wrote up here, you have to be doing it to both sides of the equation for it to be one of these 4. Okay, if you're just dividing on one side, that's simplifying. If you're dividing on both, then it's division property. Okay, I'm going to come back to the next 3 in just a second. I'm going to go on down to substitution property. That is one that you've learned before in Algebra 1. I'll show you an example of what that will look like today. So if we have something like 2x plus 3y equals 10, y equals 4. What would be the next step that you would do to solve for x? Okay, you would plug 4 in for the y here, right? That's the substitution property. You're just simply replacing a piece of one of your equation with something else. So if you have to do that in your process, you'll put substitution property of equality. This is often confused with something else we're getting ready to look at. So I'll show you the difference between these 2 in a minute, but I'm going to go ahead and write substitution property up here to remind you. Okay, so the difference. The next 3 are things you probably have never seen before. They are more specific to geometry. Reflexive, symmetric, and transitive properties. Has anybody ever heard of those before? Okay, so I assumed that was probably new for you. Okay, reflexive property you're going to see right now. Today in the lesson, we will not use very much at all, if any. Reflexive property is used more when we get to tomorrow, Friday's lesson, and we're dealing with geometry proofs, okay? And as we go further in the course, reflexive property we will use a ton. But for right now, it's not used very often. Reflexive property just simply says something is equal to itself. 5 equals 5. A equals A. In geometry, it might say something like angle 1 is the measure of angle 1 is equal to the measure of angle 1. Something's equal to itself. Okay? Again, not used a lot in algebra. Symmetric property we will use a lot today. Symmetric property says if A is equal to B, then you can flip it over and say B is equal to A. Okay, so symmetric flips. Here's where you'll use it today. When we're solving these equations, your answer cannot be, so let's say that I had 10 equals 5x. What would you do to solve? Divide by 5. So then you would have 2 equals x. Your answer is not finished until your x is on the left. If your x is on the right, you are not done. We mentally flip it over before we write it most of the time, right? So we don't put 2 equals x. We just write on our paper x equals 2. But in your proof today, and again, that's where I told you it gets hard for pre-AP kids because you've just already flipped it, you have to put 2 equals x, and then you have to flip it over and say x equals 2. And when you do that, the reason you can do it is the symmetric property of equality. Is that clear? Okay, so you are done with your proof when you have your variable solved for today. Okay, and then the last one is the transitive property. And we won't use it as much today as we will when we get to geometry, but we use transitive all the time in geometry. So the transitive is going to look like one of the laws we just talked about the other day. Transitive property says if A equals B and B equals C, notice they are both equal to B, then we can get rid of the B and say A equals C. What law does that look like? Law of syllogism, right? If P implies Q and Q implies R, then P implies R. The only reason we don't call this the law of syllogism is because that law is in if-then form, and this is equations. And so they give it a different name. This is called the transitive property of equality. Okay? There's also a little trick I can show you that will help you keep straight which one's which. But before I do that, I want to show you the difference between transitive and substitution. It is the most confused property on a test. Transitive versus substitution. So you guys are with me that if I'm just replacing one little piece, that's substitution, right? Okay, so transitive. Here's what transitive would look like. 2x plus 3, actually let me make something that might be more like what you'll see. How about 2x plus 4x equals y. Y equals 24. Okay, this would be transitive, because what would I write next? 2x plus 4x equals 24. Notice the entire left side here is identical to the entire right side. So it's like saying if A equals B and B equals C, get rid of the B, get rid of the B, A equals C. Okay, erase it then. If one whole side of your equation is identical to one whole side of the other equation, then you're getting rid of the part they have in common, just like with the law of syllogism. The part they have in common goes away, and what's left gets combined together. Okay, that's transitive versus substitution. Notice no side of this equation is identical to this side. This whole side's just y, this whole side's just 4. This is not y or 4, this is not y or 4. So if you're just replacing one little piece, that's substitution. If the entire side of the equation matches the entire side of the equation, then that's transitive. Okay, another way it could look. 2x plus 4x equals 5y. 2x plus 4x equals 32. What's the part that is identical? Okay, and again, it has to be the whole side of the equation. So this whole side is identical to this whole side, so those go away. And what's our equation? And that is transitive. But because the whole side is the same as the whole side, we call it the transitive property of equality, not substitution. Substitution is used when you're replacing one piece of that side of the equation. Is that really clear? Okay, so the last thing I'm going to show you before we practice a few problems is a little trick to keep Yes, ma'am. Sure. Here, let me write transitive under these as well. So both of these are transitive property of equality. Again. Okay, so I'm going to show you one little trick that will help you keep track of which one's reflexive, which one's symmetric, which one's transitive. If this helps you, use it. RST is alphabetical, right? RST. Notice that reflexive only has one equation. Something equals itself. Symmetric has two equations. You take one of them and you flip it over to get the other one. Transitive has three equations. You combine two to get a third. So in my mind, I always say RST, 1, 2, 3. So then when you see, yes, RST, 1, 2, 3. All right, so when you see that, you're going to think, if I have one equation, that's reflexive. If I have two equations, that's symmetric. And if I have three equations, that's transitive. So we're going to fast forward in our notes here real quick and look at the last page, but not on the back of it. Go all the way to the front of your last page. Okay, so you should see this chart on the bottom left of the last page, right? Everybody with me? Okay, notice it's exact same three properties, reflexive, symmetric, and transitive. What has changed? It's of congruence. So the only difference here is, and again, you can scratch that out if you want and use the congruence symbol, but you still have to write everything else out word for word. The only thing that's different is now you're using a congruence symbol in your statement. You're still saying with reflexive that there is one congruent statement and that something is congruent to itself. And where you're going to see that coming up in chapter 4 mainly, and you'll see it all the time in chapter 4, is if you have a picture like this, and we're trying to prove that these two triangles are congruent to each other. If we're trying to prove these two triangles are congruent, then we may need to say this side BD in triangle 1 is congruent to this side BD in triangle 2. So we're saying BD is congruent to itself. That's reflexive property. And that's where you'll use it more in the geometry side, less in the algebra side. Okay? But we would be using reflexive property of congruence when we do that because we're using our congruence symbol. Symmetric is still two equations. If one's congruent to 2, you can flip it. 2 is congruent to 1. And then transitive is still 3. If PQ is congruent to RS and RS is congruent to TU, like the law, get rid of the RS's, PQ is congruent to TU. Does that make sense? Okay? And so every time when you write your answer, your reason, you're looking to see, does this symbol match this symbol in your statement? Those should always be the same. If it's equality, then it's of equality. If it's congruence, it's of congruence. Are we good? Okay, so let's practice. If you look at the next slide here, we'll do this one together, and then you guys can try the last 4 on your own. This is not a proof. This just says identify the property that justifies each statement. So which one of the properties are we using here? So on A, what says QRS is congruent to QRS? Reflexive property. Yes, reflexive property of congruence. And again, that symbol should match the symbol in your statement. All right, what's B? Okay, it should be symmetric. You're saying if 1's equal to 2, you're just going to flip it. 2 equals 1. Again, notice there's only 2 equations. RST, 1, 2, 3. So S is 2, so that's symmetric. Most misspelled word in this section is symmetric. Symmetric has 2 M's. So I'm going to help you, right? I'm trying to point out every time and make you better spellers and all of that. Symmetric property of, careful, of equality, because it's an equal sign in our statement. They should always match. All right, C. What's C going to be? Good. Transitive 1, 2, 3. So first of all, that gives you a hint. But also notice that they have CD in common. So we're getting rid of the CD to say AB is congruent to EF. So transitive property of congruence, because the symbol is a congruent symbol. And what's the last one? Very good. Reflexive, and it is flex like your arm. You're going to flex your muscle, not flect. Reflexive, so with an X. Okay, you're not reflecting it, it is a reflex, like you're flexing. Reflexive property of equality. Any questions? Okay, go ahead and do the next ones on your paper and we'll check them. Okay, let's check. It looks like you're all getting finished there. I'm going to call on you, so be ready. So, first one, 4A. Kelsey, what did you get? Very good. Symmetric property of equality. Do not abbreviate. Bad to look at what they did, but symmetric property of equality is correct. 4B, Spencer, what'd you get? Very good. Reflexive property of equality. Ohm, 4C. Careful. Notice that, very good. The symbol here is an equal sign, so it's transitive property of equality. And then 4D, Riley? Very good. Symmetric property of congruence. Any questions on those? Okay, so what we're going to do next is we're going to start actually working through algebraic proofs. So if you'll flip back in your notes, there was one property that I skipped that's in your notes that you'll also use when you're solving these algebraic equations. And I don't know why they put it on a different page instead of just putting it in the chart. But it's not here in our chart, it's on the next slide, the distributive property. So you know that, you've used it in algebra a bunch. It's just you need to be able to explain what you're doing in your proof. So if you have to distribute A, then you use the distributive property, but add here, everybody, right now, it's distributive property of equality. They're all of equality that we're learning today, or of congruence if it was one of the last ones. Okay, so make sure you're putting of equality. So we're going to practice setting up our first proof. Our proofs are always going to look like what again? A T-chart, okay? 2 columns. So you're going to start this. It did not say write a proof, though. What it's going to say today when it means write a proof is write a justification for each step. If you see that phrase, you're going to know that means write a 2-column proof, okay? What's going to go on the left? Statements. What's going to go on the right? Reasons. Okay? 95% of the time, your very first statement will be given to you. There are some times that you're going to want to start your proof with something other than what was given. But most of the time, your very first statement will be something that was given to you, which means your very first reason would be given. Okay? There will be about 5% of the time probably where there'll be some times you start with something other than what was given, but you will still be given some information that will then go later in your proof. If it was given to you, the reason is given. Today, all of our first steps we're going to start with for algebra will be the actual equation that they give us to solve. So our first statement will be whatever we're trying to solve. So you'll just write your equation down. 4m minus 8 equals negative 12. Okay, and this is the first and probably only time I'm going to tell you that I don't want you to show work. Never do I say that. In a proof, you are not going to show your work, you're going to show your results. So if you don't need to show work, you don't have to. If you need to, you're going to go over and write your equation on the side of your paper somewhere and do your work over here. So what I mean by that is, what would be the first step to solving this? Add 8. You are not going to write add 8 in your proof. You can do it over to the side, or you can just do it mentally in your head. What do you get after you add 8? 4m equals negative 4. That is what you put as statement 2. 4m equals negative 4. And how did we get from what was given to that step? What did we do? Addition property. So number 2's reason is just addition property of equality. When we get back from lunch, we'll finish it. You guys can go. Okay, so back to where we left off right before lunch. We were solving our equation. We used addition property. You are not going to show your work in your proof, but you can show it out to the side if you need to. What would we do next? Divide by 4. Again, you're not going to show the step of dividing by 4. You can do that over to the side if you need to, but you're going to put what the result would be. So what do you get after you divide by 4? M equals negative 1. What property did you just use? Division property of equality. All right. Is our M on the left? Yes. Remember, your variable has to be on the left, or what property would you have used if you had to flip it over? Not reflexive. Symmetric. Symmetric flips it. It takes one equation and creates a second equation, okay? So that's symmetric, but we don't need to use symmetric because it's already there. Okay, we're going to skip the next one because it is just the same exact thing, and it's really quick, super simple. So we're going to skip this one, and let's go to one that's more of a word problem. You will have some word problems on your homework, and we are going to set up one at least, hopefully if we have time today, on the homework and do it together. It says, what is the temperature in degrees Fahrenheit when it is 15 degrees Celsius? Solve the equation for F and justify each step. And again, when you see that justify each step, you're going to think, write a proof T-chart, okay? So 2-column proof is what we're calling it. Left side is statements. Right side is reasons. Okay, a little bit of help when you have word problems. When you have a word problem, you're going to have to read through it all, bless you, and pick out what they're giving you out of that word problem. And there is one on the homework, I think, where you have to develop the actual equation. It's not really listed for you, but it would still be given. You're reading the information to create a equation, and when you do that, it would be given. So you're going to read through here and list everything that's given to you that's needed for this problem. So what is for sure one thing we're going to use? Say it again. The equation they give us. F equals 9/5 C plus 32. And that again is given. That's our reason. But there's more information that they give us that we need in the problem. What else does it give us? Okay, they tell us what C is, 15 degrees. So the way we would write that is C equals 15 degrees. Does that make sense how you're going to pick out that information? Okay. It is the same reason, so when you have the same reason and they don't depend on each other, you can just list it all in one statement if you want, or you can separate it and put it in 2 statements and it would be given again. But it is fine if you list several things. The only time you can't do that is if you had to know the first one in order to get the second one, then you would need to write them as separate statements. But both of these just came from the paragraph. Everybody okay with that? Okay, so then step number 2, we're supposed to be solving this equation for f. So what would be the first thing we need to do? Okay, plug it in. So what's the reason when we plug something in? Very good. Substitution property of equality. Okay, I'm going to go ahead and write my reason before I do it, just so I don't forget what it is I'm doing, and that'll make my reasons easier to write. When you substitute it, make sure you don't do multiple steps at once, because a lot of the times with your being so smart, you want to do too many things at once. Substitution means we're just plugging it in. So f equals 9/5 times 15 plus 32. So we just substituted. Now what do we need to do? Okay, be careful. Distributive, yeah, distributive would be if there was more than one thing in our parentheses. Okay, we need to multiply the 9/5 and the 15. Is that going to be multiplication property? Okay, it's like combining like terms. You're not doing it to both sides of the equation, so it's not the multiplication property. But it is combining like terms or simplifying, and you can use either answer. So number 3, I'm just going to write simplify because I would rather not write as much. And then you're going to simplify. So 9/5 times 15, by the way, when you don't have a calculator, make sure you're making that math easy for yourself. Don't multiply 9 times 15. Cross cancel first. 5 will go into 5 how many times? And 5 will go into 15? 3. So then multiply straight across. And remember, 15 is 15 over 1, not 15 over 15. So what does this become? 27. So try to do things that will make your numbers smaller before you make them bigger. Okay, so then we have f equals 27 plus 32. And then what's the last thing we need to do? Okay, add those. Is it the addition property? Nope, it's still just combine like terms or simplify. Again, I'm a little bit lazy, so I'm going to put simplify. And this would be f equals what? 59, and this is degrees. Yes, good. Don't forget your units. Is our variable on the left? Good, so we do not need the symmetric property, and we are done. Is this making sense? Okay, so let's look at some problems that are going to lead us to geometry proofs. Okay, so before we get going, I want to remind you of the notation that cost us points. Still in my other class that's fast-paced, we're still debating this every day. I don't know, I'm either not doing a good job or I've got a few people who aren't paying attention. I don't know which one it is. It could be both. I want to emphasize one more time. What does this mean? 2 capital letters side by side, nothing above it. Distance. Distances are equal. You have equals, not congruence, and they equal a number, right? What does this mean? Line segment AB. Segment AB. That's what this means. Segments are congruent, so you could say a segment is congruent to a segment, but you do not say a distance is congruent to something. A distance is equal. There is no line segment when you're talking about distance and numbers. There is a line segment when you're talking about congruence to another segment. Does that make sense? Okay, and that's going to continue to haunt you if you're not careful. Okay. So now this is our baby geometry proof. Okay, there's 2 proofs left in the notes that we haven't done, this one and one more, and they're both going to help us just kind of start the process to doing geometry proofs. It's mainly algebra. And here's the part where I feel like you guys are probably going to want to skip some steps, and you can't skip steps. So we had problems just like this back in chapter 1. What do we need to do here to solve or write an equation? We need to use the segment addition postulate. When you did the homework over this in chapter 1, you just went right to writing an equation, right? In a proof, you have to list what's given to you, and you have to list how you know it, and you have to list how you know this equation. So there's all these steps you have to do. So let's start. Statements and reasons. And this is one of those times that you may not want to write your given first. Could be that you want to go out of order. Because the first thing Caleb noticed was we need to use what? Segment addition postulate. It's not given to us. They didn't write anything down and say this is what you're given. What's given is what's in the picture, but he said I think we need to use the segment addition postulate. So I'm going to start my reason over here with segment addition postulate. We do have some given and we will need to list it, but I'm going to wait. We could have put it first, so it doesn't matter. The order here could be switched. Okay, here's the other part that's kind of hard sometimes for students. The segment addition postulate, if you look back in your notes, did not talk about a variable expression plus a variable expression equaling a variable expression. It talked about it in terms of distances and the names in the picture. So what should our segment addition postulate say? Okay, I'm hearing good things. NM part plus MO part should equal NO the whole. Do I put line segments above those? No, never if you're using equals or addition or subtraction. It's always the distance plus the distance equals the distance. All right, then from there, what are we going to need to do? We're going to need to use substitution. We're going to need to plug things in, but we don't have anything in our proof to plug in. So we have to list our given. And this is where sometimes your given isn't listed, given this, it's just in the picture and you've got to pull it out of the picture. So we're going to write down our given. We are given that NM is equal to what? 2x. We're also given that MO is equal to what? 3x minus 9. And then the last thing we're given is NO. What is NO equal to? 4x minus 4. And all of that is listed in the picture, so it is given. And I'll say again, those two things could have been switched in order and it would be fine. So you could have listed your given and then said, I need segment addition postulate. What you can't do is start with the equation, because these two steps are needed before you do. So now we're going to do what Savannah said, and we're going to plug in or substitute. So number 3 is substitution. Property of what? Equality. And now when we substitute, what will be our equation? Good, I'm just listening to Is everybody following him? 2x plus 3x minus 9 equals 4x minus 4. And then from here, it is exactly what we did the last few times. It's just solving algebraically, backing up every step. The only thing that's really geometry was the segment addition postulate part. Does that make sense? Okay, let's go ahead and we'll solve this one, and then we'll just set the next one up and stop. So if we want to solve this, what do? Combine like terms on the left. We've got a 2x and a 3x. Do not mark this, but I'm doing it up here on the board. Remember not to mark on your proof. So what does this become when I simplify it? Good. 5x minus 9 equals 4x minus 4. And my reason? Simplify or combine like terms. Okay. What do we want to do next? Okay, so this is where you and your partner may have different answers, or you in the back of the book may have different answers. Because to solve this equation, there's a couple different ways you could go about it next, right? So I heard add 4, which means if I'm adding 4, what property am I going to use? Addition property. Addition property of equality. And if I add 4, then I would end up with as my statement. Good. 5x minus 5 equals 4x. Okay, if I work it this way, then my step 6, I would have to do what? Okay, I could subtract 4x, or I could subtract 5x. I'm going to do it that way just because it's going to work out nice for us to practice something else. Again, you didn't have to add 4 to start with, and it wouldn't put you in this position. You could subtract 4x, but then you would have to add 5. So I'm going to subtract 5x instead. So if I subtract 5x, what property am I using? Okay, and if you're watching the video, I am over on the regular board, and it is subtraction property of equality for reason 6. So what would our statement 6 be? Negative 5 equals negative x. Okay, what would we need to do next? Okay, we could flip first if we wanted to, or we could divide by a negative 1, or we could multiply by negative 1. The reason could either be division property of equality or multiplication property of equality, right? Because we could either divide by negative or multiply by negative and get the same result. So there's two options for your reason here. I'll flip at the end, Vera, but you could have flipped now. It doesn't matter when you flip it. So number 7, I'm going to do division property. So 7's reason would be division property of equality. But again, it could be multiplication property. Both would be acceptable. Either way, what would be our statement for number 7? Careful. 5 equals x, right? And then like Vera said, we're not done because x is on the right. So our last step, number 8. Good. Symmetric. Remember 2 m's. Symmetric property of equality. And then when we flip it over, our final statement, number 8, is x equals 5. That could have been done a little shorter if we would have done it in a different order, but it doesn't matter. When you're solving the algebra proofs and even geometry proofs, there's going to be some people that do them the easy, short way. Some people will see it a different way, and it may be a little longer. Doesn't make them wrong. Okay? Just makes it more challenging for me to make sure I'm grading correctly because there's lots of different options. Any questions? Okay, last example in your notes is we're just going to set it up. Once we get to the algebraic equation part, we're going to stop because then you could finish that on your own. So let's set this up. Same kind of idea. Write a justification for each step and they give us a picture. We're supposed to solve for x. What's the first thing you notice that we're going to have to use here? Very good. It's angle addition this time because our picture is about angles. And we know part plus part still equals the whole. And so that stuff in chapter 1 is still following us, and it will all year long. Doesn't go away. But it gives us a chance to practice and get better at it. So statements and reasons. Number 1, we could start with our given, or we can start with the angle addition postulate. I'm going to go ahead and start with angle addition postulate. And again, just like on segment addition, you shouldn't be starting with those algebraic expressions. You should be starting with the angle measures, the names of them. So what would this look like? Okay, be careful that you put measure of angle, ABD, plus the measure of angle, DBC. Good, equals the measure of angle, ABC. So part plus part equals the whole, and making sure to put those little m's, chapter 1 notation, when you're using pluses and equals. We're talking about their measurements. All right, and then just like the last one, what's the next step that we need to do? Before we can substitute, we have to list the given, right? Substitution is where we will go after this, but we have to list what was given to us in order to have something to substitute. So we'll start with the measure of angle ABD. What does it tell me the measure of angle ABD is? Good, 3x plus 5. And then the measure of angle DBC, 6x minus 16. And then the last angle, measure angle ABC. Good, and be careful in the book. Notice it's listed way down here, and it might be something in the book you miss or you don't notice with it being kind of crazy all over your paper. But it is there, 8x. Okay, and then last step to set up the equation would be the substitution property. So number 3, we would use substitution. Property of equality. I don't know why it keeps erasing what I'm writing. And then what would our actual equation turn out to be? Good. Is everybody agreed there? And then can we stop there and just say from then we would keep going and solve and back it up with all our properties? Okay. They are two separate steps and you have to do them separately. Okay? And both would be simplified. I like your question. So the question, in case you didn't understand, was since we're combining like terms, do we have to write it twice? And I want you to write it twice. I don't want you to skip and combine steps because I don't want us to get in that bad habit. So this would be 9x, and then we would, actually, I think I'm okay if you do it all at once. I think for this part, because they don't really depend on each other. If they depended on each other, I would say no, but they really don't. You can combine these and combine these at the same time, and it's all combined like terms. So you could say 9x minus 11 equals 8x and do it all at once. I'm okay with that. Good question. Any other questions? Okay, so what I want us to do is look at the homework, and I want us to look at one problem and do it together. Okay, so we're going to do one off your homework together. And then you have the rest of the time to start working on these.